Two Western Kentucky University meteorology students lent their hands in an unforgettable groundbreaking project this past summer. They traveled to Nebraska to investigate how irrigation affects precipitation. Nebraska is one of the most irrigated places in the world. Between Lincoln and York, Nebraska, lies the Big Blue River. Irrigated agriculture sits on the west side of this river, while the east side is primarily not irrigated. A 100 by 100 kilometer swath of land with the Big Blue River running right through the middle of it was the perfect spot to set up a research camp for the Great Plains Irrigation Experiment, or GreenX for short, this past summer. For 15 days straight, once in the middle of May at the start of irrigation season, and again in July during peak irrigation season, 6 students monitored the atmosphere's behavior. They focused specifically on the boundary layer where the ground is interacting with the atmosphere through a process called evapotranspiration. The GreenX project required an array of equipment to collect daily observations.
So there was 2 profilers, 2 sounders, and 12 flux stations, 3 dowels. We had NASA flew the L-band microwave antenna to catch the land surface conditions between observation points. And then we had roughly 65 mesonet stations.
Students and scientists from WKU, the University of Alabama Huntsville, University of Nebraska Lincoln, University of Colorado Boulder, the Center for Severe Weather Research, and National Center for Atmospheric Research, better known as NCAR, all came together to man that equipment and collect continuous data. Most of the equipment was used to measure correlations between things like temperature and momentum near the surface. Weather balloons were launched every 2 hours to monitor vertical changes in the atmosphere. NASA also assisted by mapping the land between observation stations using airborne remote sensing radio frequency technology to measure spatial patterns of soil moisture. The 2 WKU students chosen to participate in this data collection process, CJ Paget and Brandon Wasilewski, manned one of the DOWs, or Doppler on Wheels, mobile radar units.
We were both on the afternoon shift, which was from like noon to about 9:30, 10 o'clock at night. But then when there was severe weather, we would either go in early in the late morning or later in the evening. So one night I was out in the field until about 2 a.m.
They collected about 2 terabytes of data from 5 to 7 computers on the Dow each day.
It was a very amazing experience. It was very nice to see the real world applications of collecting data and just seeing how it can be used in everyday life, and just communicating with a lot of people about how what they do with irrigation, everything can affect the weather.
From all of the data they collected, it will take about 6 months to convert it from raw data to data suitable for scientific studies. Once this data is usable, staff at WKU and scientists at NCAR will work together to put it into numerical models for meteorologists to get a better understanding of how irrigation directly affects precipitation. This topic is becoming more and more important because with a growing population comes a growing demand for food, which means increased irrigation. The results of this study will also be relevant to us here in Kentucky.
You do have land surface changes in western Kentucky that sort of mimic the role of irrigation. So irrigation is directly wetting the surface, whereas when you have land surface changes, you're doing it indirectly. Because of different characteristics, some soils are wetter than others, so you can see different amounts of surface fluxes based on the different land surface characteristics. So what we've done in Nebraska is certainly more than applicable here in the Commonwealth.
Reporting in Bowling Green for WNKY News, I'm Christy Stewart.